Hello to all my viewers. This is Dr. Dhaval Maheta, and today we are going to discuss how to run hierarchical cluster analysis in SPSS. Cluster analysis is a statistical technique used in social science to group individuals, objects, or variables that are similar to each other into clusters. This method helps researchers identify patterns and structures within the data, facilitating the understanding of relationships and group dynamics. Cluster analysis is one of the advanced statistical techniques used to identify, classify objects or cases into homogeneous sets that behave similarly or show similar characteristics. In a simple language, we can say that the group having similar feature is classified as cluster. The analysis used to classify these clusters is known as cluster analysis. Let's take the difference between factor analysis and cluster analysis. I've already uploaded the video on factor analysis, kindly refer to my playlist. Objective in case of factor analysis is to reduce the data dimensionality by identifying underlying factors. In case of cluster analysis, the objective is group similar data points into clusters. Data type required in factor analysis is usually continuous variables, while in case of cluster analysis, we can work on continuous as well as the categorical data. Primary use, data reduction and summarization. Here, the primary use is data segmentation and classification. Output, factors, that is, a latent variables that explain variance in the data. Here, the output is clusters, the group of similar data points. Technique, statistical technique to find the latent variables. Here, grouping technique based on similarity or distance. Methodology involves calculating the factor loadings and scores. Here, involves calculating distance and updating centroids. Assumptions assumes linear relationship among variables. Here, no strict assumptions about the data distribution. Applications, psychometrics, social science, marketing research. Here, the application is market segmentation, image processing, bioinformatics. Common algorithms, principal component analysis, maximum likelihood. Here, K means hierarchical clustering, DB scan. Dimensionality reduces the dimensionality of the data. It does not reduce dimensionality, groups the existing data. Interpretation of factors can be complex and subjective. Here, clusters are typically straightforward to interpret. Dependency, variables are assumed to be correlated. Here, no assumptions of correlation between the variables. Variable relationships, it identifies the relationship between variables. And in cluster analysis, we identify the relationship between observations. Now let's understand this concept in SPSS. In SPSS, in column, we are having the variables. So factor analysis runs on variables, whereas cluster analysis runs on cases. Now we will understand the concept of cluster analysis with these shapes. In how many ways we can cluster these shapes? So we are having shape, color. The first one, according to shapes. So we will give the name to this cluster as triangle, the cluster of triangle, cluster of square, cluster of circle. According to the color, cluster of yellow, cluster of blue, cluster of green, cluster of red. Summation of internal angles. This is 360 degree and this is triangle. Types of data. It can work on continuous as well as the categorical data. So the interval scaled variables, binary variables, nominal, ordinal and ratio variables, variables of mixed types, it can work on all of them. Examples of cluster analysis in market segmentation, customer segmentation. Companies use cluster analysis to segment their customer base into groups with similar purchasing behavior, preferences, or demographics. This allows for targeted marketing strategies and personalized customer experiences. Product positioning. By identifying clusters of products that appeal to different market segments, businesses can better position their products and tailor marketing campaigns. Public health. Disease outbreak investigation. Health organizations use cluster analysis to identify patterns in disease outbreaks, determining which populations or regions are most affected and devising the targeted intervention strategies. Health risk assessment. Cluster analysis can group individuals based on health-related behaviors or risk factors, helping in the design of preventative health programs. Social media analysis, user behavior. Social media platforms use cluster analysis to group users with similar behaviors, interests, or interaction patterns. This information is used for content recommendations and targeted advertising. Community detection. Identifying clusters within social networks helps in understanding the structure of online communities and the spread of information or influence. Crime analysis, crime hotspot detection. Law enforcement agencies use cluster analysis to identify crime hotspots by analyzing spatial and temporal patterns of the criminal activities. Offender profiling. Clustering criminal profiles based on behavior patterns, modus operandi, and demographic characteristics to assist in investigations and prevention strategies. Sample size. According to Foreman suggests a minimum of 2 into m cases, where m is the number of variables. For example, if you have 10 variables, you need at least 20 cases. 2 into 10. Dalnica recommend a minimum of 100 cases regardless of the number of variables to ensure the stable variables. Everett proposed that a number of cases should be at least 5 times the number of variables. For instance, if you have 10 variables, you need at least 50 cases. For hierarchical clustering, Burns and Burns suggest a minimum of 150 cases to avoid overly fragmented clusters. Hare recommends considering the purpose of the analysis, the heterogeneity of the population, and the desired precision of the results when determining the sample size. They advocate for a balance between the statistical power and practical constraints. Hierarchical clustering is a method of cluster analysis which seeks to build a hierarchy of clusters. It is divided mainly into two types: agglomerative, that is bottom-up approach, and divisive, top-down approach. Agglomerative hierarchical clustering. In agglomerative hierarchical clustering, each data point starts in its own cluster and pairs of clusters are merged as one moves up the hierarchy. Divisive hierarchical clustering. In divisive hierarchical clustering, all data points start in one cluster and splits are performed recursively as one moves down the hierarchy. Let's take the example. In this example, we are having 5 fruits: apple, orange, pear, grapes, and banana. We are discussing the bottom-up approach, which is agglomerative hierarchical clustering. Now, these fruits will be merged based on their shapes, color, and taste. So, the first clustering. So, this cluster formation is on the basis of shape. This is on the basis of color, the green color. First cluster. Second cluster. So again, the banana is clustered here. And the final cluster, where all the fruits are in one cluster. Now let's talk about the divisive hierarchical clustering, which is top-down approach. We start from the top cluster. We go on dividing. Cluster formation. Clusters are formed in data clustering algorithm based on the distance between the data points, which measures their similarity or dissimilarity. The process involves grouping the data points into clusters where points within the same clusters are more similar, less distance to each other compared to the points in another clusters. Different clustering algorithms use various distance metrics, such as Euclidean distance, Manhattan distance, or others to quantify the distance between the data points and determine cluster formation. This iterative process aims to maximize intra-cluster similarity and minimize inter-cluster similarity, ultimately resulting in the formation of cohesive and distinct clusters in the dataset. Distance measuring between two clusters. Some methods. Euclidean distance. Imagine you are in a city and want to know the straight line distance between the 2 points. Euclidean distance is like measuring its direct as the crow flies distance between the 2 locations. It's the shortest path you could walk between them. Imagine that you are standing on the terrace terrace of the building, and your friend is standing on the another terrace. The distance which you can measure directly, the eye to eye contact, that is a Euclidean distance. Manhattan distance. Imagine navigating a city where you can only travel along the streets that form a grid. Manhattan distance measures the distance you would walk to get from one point to another by moving along the streets and then making right angle turns to reach your destination. It's named after the street grade layout of Manhattan, New York City. So if I want to reach from here to here, I can only move in right angles. So 2 to 1, then 1 and 2. It's basically a grid layout. Then the last one is Chebyshev distance. Imagine you can move like a king in a chess square, either straight or diagonal across the squares. Chebyshev distance measures the shortest path a king could take on the chessboard to move between two squares. It considers movement in both straight and diagonal directions to find the maximum distance between the 2 points on a grid. So if I want to reach from here to here, the freedom is I can move straight, that is horizontally, vertically, as well as diagonally. Steps of hierarchical clustering. Calculate the distance between every pair of data points using a distance matrix, that is a Euclidean distance. Don't worry, you don't have to do it. The software will do on its own. Then merge the closest clusters. Find the pair of clusters that are closest together and merge them into a single cluster. Update the distance matrix. Recalculate the distance between the new cluster and each of the old clusters. Repeat steps 2 and 3 until all points are merged into a single cluster. Distance between the two clusters. Some methods. Single linkage, the nearest neighbor. In this method, the distance between two clusters is determined by the distance of the two closest objects, nearest neighbors in the different clusters. Single linkage. These two clusters are there. We will find the distance between the nearest neighbor. Complete linkage. For this neighbor. In this method, the distance between the clusters are determined by the greatest distance between any two objects in the different clusters, that is a furthest neighbor. You can see here cluster A, cluster B, furthest. Group average linkage. In this method, the distance between two clusters is calculated as the average distance between all pairs of objects in the two different clusters. Average linkage. One more method is there, which is centroid linkage. We calculate the centroid of cluster A and then cluster B, and then we find the distance between these two centroids. One more method, which is quite popular. The name of the method is Ward's linkage. In this method, we try to minimize the variance of the merged cluster. Ward's method is preferred in cluster analysis because it tends to produce compact, homogeneous cluster, that is, equal size clusters that are stable and interpretable, making it robust and reliable choice for hierarchical clustering. Now let's run the cluster analysis in SPSS. So this is a data set. In the first column, we are having the brands of the car: Mazda, Datsun, Hornet, Valiant, Mercedes. The variables are miles per gallon, that is a mileage, number of cylinders in the car, displacement, horsepower of the vehicle, rate, weight of the vehicle, Q-sec, that is water time, V and S, that is a vertical or a straight engine, that is V-shaped or straight engine, AM 1 and 0, automatic or manual transmission, number of gears, number of carburetors. Now we want to find out that on the basis of these features, which cars are similar to each other. Okay, so we'll go and analyze, classify, hierarchical cluster, analyze, classify, hierarchical cluster, activated. Now only transfer the features in variables and model in cases. So at present, the cluster formation is on the basis of cases. We can also activate according to the variables, but we want to cluster cases. That is, we want the cluster formation of this branch. Statistics, don't click anything. In plots, dendrogram, horizontal, method. So from here, some of the popular methods are between group linkages, centroid clustering, and wards method. So at present, I'll keep between groups linkages. You can have a different output and compare this output. That is, you can activate different methods from here and compare the outputs. Standardize. If your variables are having large difference, let's understand this concept. See, MPG is in 2-digit, okay, weight 1 digit, gear 1 digit. But if your variables, let's say there is an income which is in 6-digit, and there is weight which is in 2-digit. So if the difference is large, then we will have to standardize it. Then we will have to standardize the variables. So at present, I will not activate this method. Save this. We will see later on. Continue and click OK. So we got the output. Now how to read this output? So there are stages. How many stages will be there? There are 32 brands of the car. So total number of stages will be one less. So 31 stages are there. So in the first stage, 1 and 2 are merged. Next stage is 12. So we will go at 12. 1 was already there. So 1, 2 and 10 are now merged. Now going 23. 1, 2, 10 are merged. Now going 23. 1 was already there. So 1, 2, 10. Third number case is merged. Okay. Now how to read this? 1, 2. Next stage is 12. 1, 10. So the case 1 was clustered in stage 1. See here, 1 is already there, this one. And on 3, 10 and 11 is there. Okay. Let's repeat. 1, 2, next stage 12. 1, 10. Next stage 23. 1, 3, 24. Next stage is 1, 30. So this way, the clusters are formed. Now scroll. So we got the dendrogram. In case if you are not able to, if SPSS is not able to accommodate the entire graph, double click on it. Again, double click on it and change the aspect ratio from here. Okay. So it will shrink the graph. Now I'll copy this in the PowerPoint and let's do the interpretation. So there are 5 clusters. 1, 2, 3, 4, 5. So in the first cluster, we are having this brands of car, Mazda, Mercedes. Okay. In second, Toyota, Porsche, Datsun, Volvo. Now we will give the name to this cluster. Okay, we'll start with cluster 1. So the brands in the first cluster are this. Possible characteristics, likely a mix of moderate fuel efficiency. You can see the cluster also here. Moderate engine power and a balance of features. Suggested name, balanced performance and efficiency. Cluster 2, Toyota Corona, Porsche, Datsun, Volvo. Possible characteristics, cars with higher fuel efficiency, smaller engines, and possibly lower horsepower and manual transmission, economy and efficiency. Cluster 3, these are the brands. Possible characteristics, likely to have small efficient engines, high fuel efficiency and possibly manual transmissions. This could be compact cars known for being economical, compact and efficient. Cluster 4, brands, possible characteristics, larger cars with more powerful engines, lower fuel efficiency and a mix of transmission types. This might be mid-size to large sedans and muscle cars, mid-size and performance. Cluster 5. So these are the brands, possible characteristics, likely to include luxury and high performance cars with large engines, very low fuel efficiency, high horsepower, and possibly automatic transmission. So this is a 5 cluster solution. We can also have a 3 cluster solution now. See, I'll repeat this. So we move one level up. So now we will pick up this particular cluster. So cluster 1, cluster 2, cluster 3. As we move from left to right, that is we take large clusters. Our clusters get converted from homogeneous to heterogeneous. So we are introducing heterogeneity more. So let's go back in SPSS. Click here, hierarchical cluster analysis, and save single solution. Click on 3, continue, click OK. Let's go in the data view. So you can see here, this gives me the cluster membership, that this car belongs to which cluster. Now click here, right click, sort ascending. So all the cars which are in first cluster are displayed, second cluster they are displayed, and third cluster. So this was all about hierarchical cluster analysis in SPSS. For more videos on advanced data analysis using SPSS, kindly subscribe to my channel. You can also refer my playlist in which I have uploaded videos on data science, machine learning, and artificial intelligence. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.